Hey, good evening, AP Physics students. Mr. Gerson coming at you here. Today we're going to be talking about the energy that a capacitor can store, right? So in this problem 46 from chapter 17, I got this capacitor, right? And I got a bunch of charge stored on it. Well, Mr. Gerson, if all this charge flowed from this plate to this plate, that would be a big current, and I'll bet you that current could do work, and there would be energy stored with this charge separating, right? Well, how much energy is stored, right? I got a bunch of energy on this capacitor. How much is it? Well, we got a little formula for you today, and it's one that's on your equation sheet. And it states that the energy stored on a capacitor is equal to 1/2 the amount of charge on it times the voltage across it. And you might be thinking, why the 1/2? I mean, it makes sense if a volt is a joule per coulomb, right? This is a joule per coulomb, and charge, of course, is in coulombs, right? It would make sense that this energy, which should be in joules, would be in joules. But why the 1/2? Well, here's the deal. If we were to say, cut the capacitor off from the battery and instead hook all this charge up to, say, something that would do work for us, like a light bulb or a defibrillator or the flash of a camera. As the capacitor discharged, this plate up here would start at 650 volts, and it would eventually go down to 0 volts. So on average, it's kind of like you're getting half the voltage across there. So that's where the 1/2 comes from. Okay. Now, keeping in mind that capacitance is the amount of charge per volt, right? Or in other words, if I rearrange this, the charge on a capacitor is equal to its capacitance in farads times the voltage. I could also take this and plug this in for the charge, and I could get other formulas. For instance, I could get that it's 1/2 C times V squared. Or if I rearranged again, I could get 1/2 Q squared divided by C. So there's a couple of different permutations you can do of this equation and this equation based upon what you know. But let's go ahead and solve this problem here. We're told we have a 220 picofarad capacitor hooked up to a 650 volt battery. How much energy is stored in that system? So we know the potential energy stored in that system is 1/2 QV. Or if we plug in for Q, C times V, right? We would get 1/2 C times V squared. So in this case, that is 1/2 times 2,200 picofarads. That's 10 to the minus 12 farads times 650 squared. So if we plug that all in, we get that the potential energy stored on that capacitor is 4.6 times 10 to the minus 4th joules. Right? So there you go, physics students. Short and sweet today. The energy stored on a capacitor. And for your intriguing thing today, to get us thinking and maybe throw a little humor at you here, I want to draw your attention. Great article in the Star Tribune today. Hey, Mr. Kirsten, I want to be an astronaut and I want to go to Mars. How could I do it? Well, this is it's not NASA that's going to Mars. It's not the European Space Agency. But if you want to be a reality TV star and have your life play out on TV while you take a one-way trip to Mars, you can begin training for that as early as next year, provided that you are 18 years of age. So, if you're interested in going to Mars and being a reality TV star and an astronaut all at once, kind of an interesting article there for you. All right, nice job, physics students. We'll see you tomorrow.